Next, we will talk about an iterative way to use the shooting method. Okay, for an automatic iteration. And this is for the shooting method, and this is how we use shooting method in the program. Okay, first is still convert. Let's still use the second order ODE as an example. So convert second order ODE into two first order ODE and write it as a state space representation. So we can write d over dt z1, z2 equals to our previous example is, okay, d over dx z1, z2 equals to 0, 1, -7, -3x z1, z2 plus 0, 1 cosine 2x. Okay, so that is the state space representation. Then the second step, we will define our boundary conditions. It's really depending on what type of the boundary conditions. You can use different matrices for the boundary conditions. Okay, we have the ZBC matrices is represent our boundary conditions, which is A1, B1, W1, A2, B2, W2. Okay, and that is represented by our A1, Y1 plus B1, Y1 prime minus W1 equals to 0, A2, Y2 plus B2, Y2 prime minus W2 equals to 0. So we have, in the introduction part, we talk three different type of the boundary conditions, right? We have Dirichlet boundary conditions, okay? And that is basically as function of y only. So you have maybe y1, y2. Then that means if b1 equals to 0, you don't have y1 prime. Then you have y1 that will be w1 over a1. Okay. Then the initial value you are guessing will be the y1 prime, which is y1, y1 prime. That is W1 over A1 alpha. Okay, you guess the alpha for the Y1 prime. And that is when you have B1. So in the loop, if you B1 equals to 0, that means you don't have Y1 prime. You gave the initial guess is W1 over A1 and alpha. Okay, that is the Dirichlet boundary conditions. You may also have the Newman boundary conditions. Newman boundary condition is what? It's only have the y1 prime, y2 prime. That is your boundary conditions. That means if you a1 equals to 0, okay, the y1 prime will be equals to w1 over b1. So your initial will be still y1, y1 prime. But instead of guessing alpha for the y1 prime, you need to guess something for the y1, which is alpha and W1 over B1. Okay. And this is the values you are giving from the problem side. And this alpha is guessing what is the initial for the Y1. Okay, this is for the Newman boundary conditions. You may also have Robin boundary conditions. And Robin boundary conditions means that you have mix of Y1 and Y2 prime or Y1 prime and Y2, right? Then that means if A1 is now to equals to 0, B1 is now to equals to 0, then you have, for example, Z0 will be equals to Y1, Y1 prime, still the same. You have, for example, you know alpha for the, you guess alpha for the Y1, and you have W1 minus A1 alpha over B1. That is your y1 prime. Then that is basically your initial guess for the Robin boundary conditions. The Robin boundary conditions can be, for example, 0.2y1 plus 0.8y1 prime minus some value equals to 0. That is also a Robin boundary conditions. Then you guess y1, you will correspondingly get what is y1 prime. Okay. And for example, our boundary conditions for the example, you have y naught equals to 1, y pi equals to 0, right? And this ZBC matrix, how you write if you have y1 and y2. So the ZBC will be equals to, you have y1, you don't have y1 prime, which will be 0 for the b1 prime. And the y1, so when y naught equals to 1, ay1, let's assume ay1 equals to 1, right? So 1 y1 will be equals to w1, w1 will be 1. How about the second point? You can give y2 equals to 1, so you have y2, which is y pi here. You don't have y pi prime, that will be 0 here. Then y pi equals to what? Equals to 0, right? So you have the ZBC matrices is here, and you have B1 equals to 0. It will follow this initial guess. The Z naught will be equals to W1 over A1 will be 1. And you give an initial guess alpha for your initial value. Then you will solve this as a shooting method. Okay. Then the next step, after you define the ZBC, the next step, so that will be the third step. Okay. The third step, after you defining the ZBC matrices, which is the type of the boundary conditions, what you will do, you will solve the ODE using the initial value problem, where the initial value is your guess Z naught, right? Is your guess Z naught. And you will analysis basically the error analysis, trying to have a better guess. Then in the end, you will repeat until you your guess is meeting for the second boundary conditions. Okay, so you have the MATLAB is xy will be equals to ODE. You can choose ODE 23 or ODE 45. If a simple problem, ODE 23 is enough. You have the function, where is your state space matrices, the representation you described as a function. You have the TC TS then. So that is the range of your x value. It can be from 0 to pi for this example, like 0 to pi, right? And you will have the Z naught, which is your boundary value, 1 and alpha there. And you have the options, where the options will define your tolerance. Okay, so this is the MATLAB's format. And you will get your first arrow. So arrow 1 is based on your initial guess alpha. And that will be equals to A2 times Y N 1. So after you solving the ODE with the initial value, you guess the value, then you can get, okay, you can get your Y column, which will be, the first column is your Y1, the second column will be your Y1 prime. And by the end will be, basically this is Y at point of pi, okay? And plus B2 times Y N 2. So this means Y prime at point pi, okay? At x equals to pi minus W2. So that is your arrow 1. If your arrow 1 is 0, that means that is the exact your boundary conditions at point equals to pi. But your first initial guess is really hard to be the exact value, right? So you will have the error. So we have the error analysis. If the absolute of your error one is smaller than the tolerance, then you are done. You finish it. Your guess is exactly similar as your final solutions, but in general, it couldn't be. So if the absolute error over the tolerance, then you will give another guess, right? Another guess. For example, alpha p, alpha p. This is another guess where the initial alpha p can be a perturbation based on the alpha 1, where the alpha p is a perturbated value based on alpha 1, so alpha. And this alpha p will be equals to alpha times 1.0001. As I said, it's a perturbation based on the initial value. Then you will have the z naught or zp will be equals to 1 alpha p, right? And based on this alpha p, you can get the arrow 2. So it's arrow p and construct arrow p. So the arrow p, after you run the initial value problem with this initial value zp, you will get arrow p will be a2 times yp and 1 plus b2 times yp and 2 minus w2. So similarly, this yp is basically yp means at x equals to pi, and this p means your initial guess is alpha p, right? Similarly, this will be yp prime at x equals to pi with the initial guess at alpha p. Okay. Then you have both the arrow, arrow 1 and the arrow p. What you can do is give a better guess. Give a better guess, we can say alpha 2 will be equals to alpha 1 minus epsilon 1 divided by epsilon p minus epsilon 1 divided by alpha p minus alpha 1. And you can do the same thing. You can do alpha p minus epsilon p divided by epsilon p divided by minus epsilon 1 divided by alpha p minus alpha 1. It's basically this better guess is given by which initial. But since the initial Z0 and ZP are pretty similar to each other, it's just based on a perturbation. So depending on which initial guess is fine to give the better guess. Then the sixth will be repeat until the arrow, the absolute arrow, is smaller than the tolerance, and done. Okay, so this is how you can solve an iterative shooting method using, inside has initial guess, perturbation guess, and give a better guess based on the error analysis.